We're finishing up the very last part of our lesson on factoring binomials. The last question on this paper says, when is the variable in the expression that is being factored also a greatest common factor? And what do you notice about the x-intercepts when the variable is part of the GCF, such as this? This equation is exactly the same as this equation here, that last example. And when we factored this, we discovered that it was p times p minus 10. And what they're talking about here is they're talking about, do you see a p in both of these terms in the expression? What they're doing is they're pretending, well, they're not pretending, they're actually saying, what if p was a GCF? What if I divided p out of p squared? Well, that would just give me p. And what if I divided p out of negative 10p? That would just give me minus 10. So they're saying that this variable acts like a GCF. And what we see in previous examples is that when that variable acts like a GCF, that variable says that the intercept is at 0, 0. The same thing happened up here. This x squared and this 12x, there's an x in both of these terms. So if I factor that out and think of it like a GCF, whenever that variable is there in front of the parentheses, that turned out to be an x-intercept at 0, 0. Now let's go back to that real-world example to finish it up. We said here that the maximum profit that we could have for the number of t-shirts in this example turned out to be $62.50. And we were able to find that by looking at the line of symmetry using this formula from the standard form, and then finding the vertex by taking that line of symmetry and substituting it back in. But that's what happens in standard form. This lesson is about factoring binomials. And what we learned when we visited this before is that this binomial expression here is written in standard form, but we only at that point knew how to factor trinomials. But now we know how to factor binomials. Is there a GCF between these two terms? Why, yes, there is. It is negative 10, which would leave us with x squared minus 5x. And if I think about an area model, I would have x squared and negative 5x. And then I would ask myself, what times what would make x squared? That would be x times x. And x times what makes negative 5x? That would be negative 5. This would be x minus 0 here. This would be x minus 5 here. I suppose you could put plus 0 if you wanted to. But again, nobody's going to write it this way. They're going to write it as negative 10x times x minus 5. If I take this factor and set it equal to 0, if I divide both sides by negative 10, that is x equals 0. And if I take this factor and set it equal to 0, then that is x equal to 5. So my intercepts for this function are going to be at, 0, 0 and at 5, 0. And that was true. In this picture here, my intercepts were at 0, 0 and at 5, 0. The line of symmetry is halfway in between the x-intercepts. Always, it has to be. So if I say what's halfway in between 0 and 5, that would be 2.5. That is my line of symmetry. And then again, I could take that line of symmetry, which is halfway in between here and here, take that line of symmetry, and I could take it and I could substitute it back into the equation to figure out what my maximum profit would be. You don't have to do that right now. We're going to have plenty of opportunity to practice that later on.